Dear students, today I will teach you Legendre function as a part of special functions. I start with explaining generating function for Legendre's function. A generating function means a function which can generate the required function. Like here written, to prove that p n x is the coefficient of h power n in the expansion of 1 minus 2xh plus h square whole power minus 1 by 2 in ascending powers of h. Mathematically, it is expressed as 1 minus 2xh plus h square whole power minus 1 by 2 is equals to sigma n equals to 0 to infinite h power n p n x, then several inequalities mod x less than equals to 1 and mod h less than 1 are given for validity of binomial expansion 1 minus 2xh plus h square power minus half, and that actually means that while expanding 1 minus 2xh plus h square whole power minus 1 by 2 in ascending powers of h, we will find p and x, that means Legendre's function, as a coefficient of h power n. Let's talk about the solution part. Proof. We start with the binomial expansion 1 minus 2xh plus h square whole power minus half, which is equals to 1 minus h, that is minus h is taken as common, so 1 minus h into 2x minus h whole power minus 1 by 2, which is expanded through binomial expansion as 1 plus h by 2 into 2x minus h plus 1 into 3 upon 2 into 4 whole multiplied by h square into 2x minus h whole square plus up to infinite, and in between we have several more terms which will be useful for further proceedings, like plus 1 into 3 into 2n minus 3 upon 2 into 4 into up to 2n minus 2 into h power n minus 1 into 2x minus h whole power n minus 1 plus 1 into 3 into up to 2n minus 1 upon 2 into 4 into up to 2n, etc., and up to infinite obviously. So in last two shown terms we are finding h power n minus 1 multiplied with 2x minus h whole power n minus 1 and h power n multiplied with 2x minus h whole power n, and here our target is to find, as written in the statement initially, our target is to find h power n and hence its coefficient in all right hand side of that expansion. And if we check in the last shown term, h power n and 2x minus h whole power n are multiplied together. If I further expand 2x minus h whole power n through binomial expansion, I will find 2x whole power n as first term, and if that 2x whole power n multiplied with h power n, which is written outside, then obviously we can find a coefficient of h power n as 1 into 3 into up to 2n minus 1 upon 2 into 4 into up to 2n into 2x whole power n, which is written in the next term. Now coefficient of h power n in expansion as it's written there, first term, and the second term is written as minus 1 into 3 up to 2n minus 1, etc. Let's find from where it is coming. In previous step, in the second last shown term, h power n minus 1 is multiplied with 2x minus h whole power n minus 1. If I expand 2x minus h whole power n minus 1 binomial using binomial theorem, I will find 2x power n minus 1 minus n minus 1 c1 into 2x whole power n minus 2 into h, and that h is multiplied with h power n minus 1, which is already existing outside, will provide us h power n. Hence coefficient of h power n will become minus n minus 1 c1 coming as binomial expansion of 2x minus h whole power n minus 1 along with 2x whole power n minus 2 and the terms multiplied before h power n minus 1, that is 1 into 3 into up to 2n minus 3 upon 2 into 4 into up to 2n minus 2. Similarly, we can find coefficients of h power n from infinite terms from that previous term. So overall, the last step of this slide is that we have obtained coefficients of h power n or infinite terms having coefficient as h power n through the binomial expansion of 1 minus 2xh plus h square whole power minus 1 by 2. We move towards next slide. Now we took common from all those expressions from the last step of previous slide as 1 into 3 into up to 2n minus 1 upon factorial n, and then the remaining terms in the bracket are obviously written as x power n minus 2n into n minus 1 upon 2n minus 1 to x power n minus 2 upon 2 square plus 2n into 2n minus 2 into n minus 2 into n minus 3 into x power n minus 4 upon 2n minus 1 to n minus 3 to factorial 2 into 2 power 4 plus 2 infinite, and it is further simplified as 1 into 3 into up to 2n minus 1 upon factorial n, same common term outside, and then inside the bracket several modifications have been made, and finally the expression is written as Pnx, and that means the coefficient of h power n in the binomial expansion of 1 minus 2xh plus h square whole power minus 1 by 2 in ascending powers of h finally came as Pnx, and the term Pnx, the symbol Pnx especially, is coming here as some kind of binomial expansion, but it is actually a solution which is a part of series solution of Legendre's differential equation, which you might have been read in second semester in series solution of any differential equation. So guys, here we complete the generating function for Legendre's function with the completion of this